number of ways to split a string. We are giving a binary string S, and you can split S into 3 non-empty strings S1, 2, and 3. So where S1 plus S2 plus S3 going to equal to S. So basically this means after the splitting there's no overlap. So for example, we can split here or we can split here, but there's no overlap. Let me make it more clear. So we have 1 0 1 0 1. So we can split it here or we can split it here like that. Yeah, basically there's no overlap because according to the formula S1, 2, 3 gonna equal to S. So we're gonna return the number of ways S can be split such that the number of ones is the same in S1, 2, and 3. So this means after each of the split, each part gonna contain the same number of ones. As you can see from the last part, there's only one. The number of 1 is only 1, and in the middle part, the number of 1 is also 1, and at the right side, the number of 1 is also 1. So this means that this is a valid split. Because there are going to be too many splittings, so we're going to return a modular value. So how can we solve the problem? Let's just analyze the examples one by one. I think the easiest example is going to be example 2. So this means the number of ones modulo 3 not equal to 0. So basically this means yeah, it can never be a valid splitting. So for the second case, so let's solve the second case first because it is much easier. First of all, let's just prepare a mod which is going to be 10 to the power of 9 plus 7. So yeah, let's at the same time let's just prepare the length of the string. So now we need to check the count. Yeah, so if s dot count with 1, yeah, but we need to know the number of the count. So maybe, yeah, let me just use a lowercase a as the number of the count. Yeah, this basically means how many ones. So let's just check the first case. So if n modulo 3, this means n modulo 3 not equal to 1. So definitely this means yeah, not equal to 0. So basically this means n modulo 3 not equal to 0 basically means there is never a valid splitting. So we're gonna directly return 0. So what about the third example? There's gonna always be 0. Yeah. So in this case, n modulo 3 gonna equal to 0, but the number of ones gonna be 0. Yeah. So what about this case? So now let's just check. So if n equal to 0, yeah, maybe let me just write it more clear. Not equal to 0 here. Yeah. So here, if n equal to 0, so basically means the number of ones is 0. We're gonna use the third example. So how can we solve the third example? So for example, we have 4 zeros. So how can we split it? We can split at this position, or this position. So this means it's going to be a combination problem. So from the 3 positions, basically we're going to choose 2 positions because the sequence doesn't matter. So it's going to be a combination of C3 with 2. Basically, the formula is going to be n times n minus 1 and divided by 2. So this is going to be the formula. So we can directly return it. Yeah. As we're going to use the length of the string, so I'm going to use the capital N as the length of the string. Now I can return it directly. So inside it's going to be n times n minus 1 divided by 2 modular a mod. So for this n, because there are only 3 positions for the third example, if n equal to 4, it's going to be 3 positions we can split, so it's going to be length of the string minus 1. So this is going to be the second case. So what about the first example? So for the first example, we just need a counter. We need to count. So for example, let me just use the first example. 1 0 1 0 1. So we need a counter to count. So for each of the split, how many ones? It's going to be n divided by 3. So for example, it's going to be 1. So we need a counter. If this equal to 1, so we're going to count it. This means from here, it's going to be a split. And if it is a 0, it means it is still 1. So we're going to have a count of 2. Now, we find another one. It means it equal to, if this is a t equal to n divided by 3. If we find another one, it means it equal to 2t. So we're going to have another count. So this is the first count. It's going to be 1, and this is a 0. We're going to continue to count another count. It's going to be 2. Yeah. So if the first count is L and the other count is R, so it's going to be 2 times 2. So how many combinations? It's going to be 4. Yeah. So we just need to check how many combinations, because here we have 2 places, here we have 2 places, but we're going to use 2 times 2. Yeah. So this is another combination mathematical skills we're going to use, because both of them are independent. So from here, from the 2 places we can choose 1, and from here the 2 places we can choose 1. Yeah. Now let's just solve that. So we're going to prepare t, going to be n divided by 2, and we're going to prepare a count. It's going to equal to 0, and we're going to prepare 2 other counts. It's going to be L and R. It's going to be 0 and 0. Now let's just start coding. We're going to check each characters. So for C inside the string, if C equal to 1, we're going to update the count. So the count is going to plus equal to 1. So if count equal to t, so basically this means we've already found one part. So we're going to update the left count. So L going to plus equal to 1. So if count equal to 2 times t, so R going to plus equal to 1. So finally, we just need to return L times R modular the mod. Yeah, so the idea is very very simple. Let me just just explain it once again. So this is our counter. From the beginning it is a 0. Now we're going to check this one. If it is 1, we're going to update the counter. The counter is going to become 1. So if this count equal to t, so basically this means we've already found one part. This is going to be 3, not 2. Yeah. If it is equal to t, we're going to update the L counter. L going to be 1. If it is a 0, it is still t, so L going to be 2. Now we find this one. It means the count equal to 2 times t. So this means R going to equal to 1. And if it is a 0, it is still okay. So we're going to plus a 1. Yeah. Now we find another 1, right? So the count equal to 3 times t. But we didn't update L and R because we've already found it. Yeah. So this is the basic idea. Let me change this to 3. Now let me just run it to check. As you can see, it works. Now let me just submit it to check if it can pass. As you can see, it passed for all testing cases, and it's pretty fast. And the time complexity is just O(n). As you can see here, this is just a formula. Yeah, O1, and this is O(n). And from here, this is a similar like to Porter's algorithm, but we just prepare 3 counters. The first counter, other 2 counters. We just prepare 3 counters: the left side counter and the right side counter. Yeah. So the time complexity is O(n), and the space complexity is O1 because we didn't use any actual space. I think that's all about it. Thanks for watching. See you next time.